Thank you for joining the Once Changing the World, India's first Future Tech Meets Sustainability podcast. And today I'm delighted and honored to have with me Mr. Charles H. Martin, who's the founder and chief scientist at Calculation Consulting, which is a machine learning and AI company that helps leading companies get ROI from data. I caught his awesome talk, TEDx, titled The Emergence of Signatures of Artificial General Intelligence. I will definitely share the link below for those who haven't seen it, and I urge that those who haven't seen it, please catch it because it's really interesting. Today the topic of discussion is going to be artificial intelligence and artificial general intelligence. So Charles, really appreciate you taking time and being part of our humble podcast. Will be great if you can start with the background and your works.
Great. Hey, I'm glad to be here. I'm glad you found my video. Somebody saw it. Eddie, I really appreciate you inviting me. Sure, let me give you a little of my background. Look, I did my PhD in theoretical chemistry at the University of Chicago back in the 90s. And a lot of people may not realize this, but AI has its roots in theoretical chemistry because chemists were studying how neurons communicate with each other. And so we're looking at the chemical signals, and chemists and physicists and mathematicians were trying to make mathematical models of how neurons, the cells in your brain communicate. I was about maybe 15 years ago now, I think about it. I was a subject matter expert at eBay a subject matter expert in machine learning. And we were studying various methods of how to improve search engines. And we had this thing called RankNet that was developed at Microsoft. We implemented this. Was a very early form of a neural network. And we had neural networks running like for cybersecurity. And I think the group that was doing that went off and became Palantir, or some guys there did that. But it was very academic. It was like, you'd bring in a student from the university, they'd give you a little bit of code, and you'd put it in production, you'd play with it. But I realized, about 10 years ago, this stuff's starting to get big again. I got to get back into the field. So I have an old friend at UC Berkeley, and we started doing research again. I started sort of cracking open the books and taking my theoretical physics approach to AI. And I was kind of lucky that most of the people who are doing AI in my time, they're all retired or gone. There's nobody left. So I sort of remember stuff that a lot of people don't remember. And I've had a lot of great success in applying these theories of theoretical chemistry and physics to AI. But I'm just amazed. I think I'm amazed as anyone else at what's going on. That I think that I think we're on the precipice of a major scientific revolution in understanding human thought. And it's just very exciting to just kind of be in this and try to figure out what's going on.
Right. How cool is that? I mean, for someone to be in the field for the longest time, seeing the various AI winters, and where people were just saying, okay, this is not going to do anything. It's not going to move to the point, right now it's completely in the hype cycle. Wherever you go, whatever any institutions you go, events you go, I think the only hot topic of discussion is AI. And you said your background is in the field of theoretical chemistry and physics, and I think these multi-pronged learning is gonna play a big role in kind of going from the current narrow intelligence at this point in time to possibly the holy grail of AI that we call about, we term the artificial general intelligence. What do you think is the current cutting edge of research, in developing AI or AGI? Because you mentioned the brains, so
I think we're sort of where the world was when the steam engine was invented. They invented the steam engine, and the steam engine was invented like in 1800 or so, maybe earlier. I can't remember the exact date. Various, toy engines that people would have on their desk. And then someone sort of figured out, we can actually make steamboats out of this, and we can make trains, and we can cross, the great frontier. But in the old days, back in the old South here in America, people they had steamboats. They would race the steamboats down the Mississippi River, and they would blow up. They'd race. It was like old version of NASCAR, like racing instead of cars. They raced the boats, and the reason is that people didn't really understand the physics of steam engines. They didn't have thermodynamics. So you would build these engines and you could get them to work, but you didn't really understand why they worked. And it wasn't really probably in about 50 years after people were using steam engines all the time, that scientists were able to figure out thermodynamics and understand how to actually design engines from scratch using scientific principles. And of course, that is now, of course, we have cars, we have rockets, that's totally changed the world. And I think that's where we are. I think that the engineers have built something like with ChatGPT and these LLMs and with the diffusion models, they've, the Gen AI, they have built something which is remarkable, but they don't really understand why it works. One of the things that's quite amazing is as these systems get bigger and trained on more data, they seem to get smarter and much, much smarter. There's an emergent property of them of getting bigger that it's difficult to study in a lab at a university with a toy model because it's just not the same. And I think that people are discovering that these things can I like to think of them as sort of like how we discovered the fly. When we discovered the fly, we tried to fly like birds. Man tried to fly like birds for a long time. You'd strap wings to yourself, jump off a cliff, and of course it didn't work. And then the Wright brothers figured out how to they figured out how to fly in a plane. They were bicycle mechanics, and they built a plane. But we didn't really understand lift and drag yet. But we don't fly the way a bird flies. And I think that a lot of people make the mistake that they think AGI is going to be just like a human. It mimics what we do, and it's better than us in many, many things, but it's very different as well. And I think that the research right now is just trying to figure out what can it do, how is it different, and what's going to happen with, say, GPT-5 when it's much, much bigger.
You rightfully pointed out, I think what these current narrow AI with the LLMs, Gen AI tools, they've got great capabilities. They can do some really, really awesome things. But underneath the hood, I think it's quite a mystery of what's actually going on. But there are these people who are working on something called explainable AI and things like that. What are your views on this? And I mean, how do we tackle this problem of understanding what's happening behind the black box? And I mean, what's going on over there? How do we
it's difficult to peer inside because you don't know what to look for. And I think a lot of, some of the work in explainable AI is driven by regulators and politicians who want to have something that they can kind of get their hands around, but they're not scientists, right? So they're asking, again, they're trying to explain how a bird flies without understanding lift and drag. So, it flaps its wings, that's the, and it's like, that's not an answer, that you can't build an airplane by trying to mimic it. And I think you have to go and try to, so my approach to this has been, let's go back to the fundamental theoretical physics and try to understand, what do we understand about these basic models and how do they relate to what we understand about neuroscience? How does the brain actually work, and what can we observe when we peer inside a brain or inside neurons cultured in a lab, and we can observe what happens in the cultured neurons, and we can observe what happens in these AI systems. And I sort of take a bottom up approach, dig inside and try to are we actually mimicking what's going on? And a lot of the people this is where the field really came from, is trying to look at neuroanatomy, neurochemistry, neurobiology, and trying to mimic what's happening by building little things and making them bigger. And now I think that, in my own work, we've had some great success. We had a big day. I pioneered this work several years ago. When I started, of course, people thought I was crazy. Like, why are you doing this? I'm like, well, you guys don't remember anything. Like, a lot of the theory has been like statisticians. People think, well, AI is just statistics. So the statisticians and the academic statisticians have gotten involved, and they had a lot of success in machine learning, like developing machine learning algorithms, the random forest and XGBoost and SVMs and things like that. But AI is totally different. And, the statisticians have tried to get involved in this, and I think most of the success they've had has been rediscovering things that physicists knew, but in a different language or that was forgotten. But it's not just statistics. And this is the thing that people get wrong. It's not statistics. It's mimicking how neurons function, how your brain cells work. And as we understand better how individual brain cells work and how collections of them work, we'll be able to mimic them in software and mimic them in silicon. And you'll be able to design structures where I don't think, see, the problem with explainable AI is that they're trying to take it from the top down. They're looking, and you have to look at it from the bottom up. You're building something, it's going to grow, it's going to do something, and the best you can do is sort of guide it. You can't control it.
Right.
And it's I wouldn't call it a living organism, but it's a complex system. And you're not going to be able to wrap your hands around it. The more you try to squeeze on it, the more it's just going to slip through your fingers.
We don't understand what's going on behind it. I mean, you said that maybe possibly mimicking a human brain, how it functions, could be a way to kind of accelerate, the approach of building an AI. But tell me, I mean, even in this current state, these large language models, where there's a lot of these data, basically this data being fed in, is doing some predictable this thing, but it's still is showing some emergent properties, and your talk was around that, and there was a couple of papers
Yes,
also.
yes.
There were a couple of papers. There was one paper which was titled "Emergent Abilities of These Large Language Models," and there was another paper by Microsoft and OpenAI titled "Sparks of Artificial General Intelligence:
Yes,
Early
yes.
Experiments with GPT-4." So what's happening behind these statistical models? I mean, how?
In 2018, there was a paper published by on prompt engineering, which was rejected by the idea that you could talk to the AI and it would respond to you. And they call this prompt engineering. You prompt it, you give it some instructions, it responds. You give it more instructions, it responds. We call it in-context learning. Nobody knows why that works. They just sort of emerge. It's an emergent property. It just started happening. And what was going on? People were just, they were interacting with these systems. They were trying, like I had a client maybe 5 years ago or so that wanted to generate fake text, Amazon reviews, weight loss articles, that kind of stuff, right? Typical kind of stuff. And we were built, and the idea is you would give it like a seed sentence and it would generate some text. And it's like, write a review for this shampoo or something like this on Amazon. And it turns out that these LLMs that people build seem to remember what you tell them and can respond. And this is quite surprising because it's not at all clear why this works. I mean, there are some people who have, suggested things, but nobody expected this. And this is an emergent property. So then what happened is you have psychologists, psychology professors, psychiatry professors, people who have models of intelligence of children. They have different tests you give a child to measure their intelligence, their IQ, how they're developing, things like this. And they started designing the tests for the AI and giving it to ChatGPT. And ChatGPT started passing the test. And they found out that as you add more and more data and you make the model bigger, when you go from GPT 3.5 to GPT 4, this thing started getting really good at passing these tests. And it's quite surprising. Like, how is this thing able to pass tests? So people started thinking, well, maybe some kind of natural intelligence is emerging in these models that's mimicking how we think linguistically, how we think about language. It's somehow able to mimic this. And that's where it started. Like, people started thinking there are emergent abilities, and it's not really clear what's going on because nobody knows what training data has been put in the GPT. So they don't know what's in it. One of the theories is that because it crawls GitHub and Stack Overflow, that it knows how to write software. And because it knows how to write software, that somehow knowing how to code has imparted in it some sort of pattern recognition ability that gives it the ability to mimic basic human intelligence. How about the intelligence of an 8 or a 9-year-old? And that's quite surprising. And that's one of the theories. Another theory is that, well, maybe the thing has just so much data that it knows everything. And so it's just like a giant memory. And when you ask it things, it's just regurgitating the test, and you're not really testing its intelligence. And I think that's the challenge with any intelligence test, right? If you ask somebody a question, are you really probing their thinking capacity, or are you probing their cultural knowledge and history and memory? So people, like right now, people aren't even sure how to design intelligence tests anymore, because how do you design an intelligence test that an AI can pass? Because we know it's not alive. So it's very challenging to know, even it's challenging our own concepts of what intelligence is and how we think about and process language.
Right. I mean, not everybody is convinced about this emergent properties. Then there's this,
Sure.
because recently I think Stanford AI team, it claimed that emergence is not an inherent property of scaling models, but rather a measurement error caused by inferior metric selections. What are your
This
thoughts on
is
that?
why I have my theory. Okay, now I
Okay.
get what I'm doing. Look, my approach to analyzing these models doesn't require any any training data, any test data, any interaction. I just look at the internals of the model. It's like an X-ray machine looking inside. So what I decided is, look, I realized when I was working with this client, we were making these sort of fake Amazon reviews. I'm like, I don't know how to tell if the Amazon review is good or bad. I'm not gonna read 50,000 of them. It would be ridiculous. So I knew I had to have some way of analyzing how well the model was doing without having to actually probe it using language. So in other words, you go to a psychologist, they're gonna go into therapy and they're gonna ask you questions. I don't want to do that. I want to do a brain scan, right? I want to do like an MRI on your brain and figure out what's going on. So that's what my tool, my theory does. And what we've discovered is that there are these signatures of emergence that were predicted in theoretical physics by a theory called self-organized criticality. It was by a physicist named Prabhak. I talk about this in my TED talk. And what I realized, I wonder if we could see these signatures if we peered inside some of these models. And it turns out you can't. It turns out you can see them, you can measure them, and I have worked out a general theoretical physics approach to explaining where this stuff comes from. It's semi-rigorous, right? This is hard to come up with something. It's not mathematically perfectly formula, but from like a physics level of rigor, yeah, it seems to actually, it seems like the mathematical equations that you use to measure and study how neurons interact in the brain, and looking at these patterns, these avalanche patterns are what they're called, they seem to appear in these models. And there's almost an ideal state. There's almost a state where every model seems to have a data set that you can align to it. And if you match them up just right, a certain kind of magic happens. Like the data. Let me share something kind of maybe something I didn't really get a chance to talk in the TED talk, but I can explain something. Look, back in World War I, when the U.S. Army started bringing in soldiers, we had a massive, we started recruiting, really drafting, thousands, tens of thousands of soldiers. The U.S. Army had to develop an intelligence test because they figure out, what could they do? Which one should be an intelligence, which one should drive the tank, which one should dig a ditch. Because you put someone who's not too smart out in the field, they're going to get killed, right? So you got to figure out what you're going to do with them. And what they would do is they would give the soldier a newspaper article, or an article from a book or something, and they would dot out some of the words, and they would ask the recruit, the draftee, please fill the words in. And so if you give someone a newspaper article and you blotch out a few words or black them out, then they have to fill the words and they have to guess the words. The better they are at guessing the words, the more intelligent they are. Or reasonably, this is their level of education. You could tell this person has an 8th grade level, this person's 9th grade level, this person's 12th grade level, this person's college level. You could tell that from that simple test. Now, I don't know if the AI guys who know this or not, but if they knew about these tests, but the AI models are trained based on those tests. What they do is they take huge amounts of text, they feed it to the AI, they block out some of the words, and they ask the AI to guess the words. And somehow by training out, and of course, this is everything they can get there, every book, everything they can get their hands on, legally, illegally, copyrighted, not copyrighted, whatever they can get, they put into this thing. And somehow being able to guess a word actually does, and having a neural network that can do this somehow imparts a type of intelligence into the system. And that linguistic intelligence emerged as this prompt engineering in context learning. It just emerged from these models. So when people say, well, there's nothing here, and we can see the signatures, I can see with my theory, as the models get bigger and they're trained on more data and they're aligned properly, the signatures of emergence get stronger. The signatures you would see in, say, cultured neurons of self-organized criticality, you see in these artificial neurons. And then the self-organized criticality, it's a balance point between order and chaos. It's a balance point between having memorized everything statically and just generating huge amounts of chaotic hallucinations, right? Because we all know these things hallucinate, right? They hallucinate, they memorize copyrighted information, right? And people complain, well, they hallucinate. Okay, if they don't hallucinate, then all they are memories. Well, then they have all this copyrighted information. Go, yeah, they're memories. You can't have both, like, so there's like a precipice between memorizing everything exactly and going crazy chaotically and hallucinating wildly. And that point is this point of self-organized criticality. And what's interesting is that using our approach, the theory I've worked out, you can actually see that as the models hallucinate more, as they get better at fooling you and creating, hallucinations or essentially lying to you, the signatures of emergence get stronger. It's quite remarkable. I was quite surprised. It's like it really does show, like, the better the model is at sort of making stuff up as it goes, the stronger the signatures of emergence. And that was the basis of my TED Talk, which was a surprising result from our research. It shocked me that this came out. So no, I think that these guys, they're, but the problem with any test is that, you go to a therapist and the therapist tells you you're depressed, and you go to another therapist and the therapist says, well, go run 3 miles and you'll feel better, right? It's very hard to say anything about an intelligent system by looking at it from the top down. You have to look from the bottom up. You need the brain scan, you need the x-ray, you need to go in and understand what you're looking at. And that's my approach. And I think that there's the controversy will continue over, is it emergent? Is it not? Should hallucinate? Does it hallucinate too much? I mean, that's just the nature of what this is. So these are hard questions, but that's sort of my take on what's going on, is that, that there really is something very unique about these systems, that they really do. There are unique properties that are emerging. Much like, look, in physics, we talk about emergence. We say, the emergent properties of a system, you take a bunch of molecules and, you just have a gas, you have some gas in a glass, in a room or something. But when you cool it down, it becomes a liquid. So when you squeeze it and cool it down, you put the water in a cup, it's a liquid. It has totally different properties than gas vapor. It's totally different. It's a phase change. You have these emergent properties that happen when you have lots and lots of things put together. And I think that's what's happening in these AI systems, is that we've built something that mimics how our brain cells work in a very crude way, but we put millions of these things together, and now something is emerging that kind of looks like intelligence, and it mimics us in a way. It's like a child that we had, but we're not sure who the mom is. Maybe don't know who the dad is, and that's really it. It behaves in a strange way, yet it seems to be intelligent.
Right. Yeah, so it's quite funky, because I think we live in a very complex world, and it's a dynamic world, and this emergent properties of it, which you are kind of observing through your theory. I mean, it sounds weird, but I mean, I guess possibly maybe even nature kind of functions, in a similar way. You mentioned that, you had been to this event where 15,000 others
Yeah,
Do
yeah,
you do
yeah.
you, do you, do you have like a kind of sense of what's happening around the world, the cutting edge of technology when it comes to building these uh, uh, maybe self-learning autonomous agents, artificial general intelligence? What's your
Well, that's why I'm
what,
still in San Francisco. People ask, why are you still there? Because I don't know if you watch anything on the news on San Francisco, but this is a crazy place. But if you go to a Starbucks, if there are any left open, you go to a meet, there are all sorts of meetups and hackathons and venture capitalist lunches and casual coffees, and everybody's doing this here. They're all trying to figure this out. So you have people trying to do agents, people trying to generate fake text, people trying to create tomorrow I'm going to listen to a talk at Stanford um, about a group that's trying to build a general artificial intelligence for medicine. They're going to try to train an AI on all medical documents. I have another associate who trained GPT to pass the bar exam. So they're trying to make legal AIs. I think that it's just everyone now, like the race is on to just build whatever you can build. And I say it's like they're building steam engines. Their race is on to build what you can and to try to figure out what works and what doesn't. And I think the engineers are going to be way ahead of the scientists for a long time because they're just trying. Like, there's a joke, and I have a friend who's actually the guy who's part of this. There's a group called Noise Research, and they just got funding and open source funding to fine tune very, very large open source models. And sort of the joke is that you have all these PhDs from MIT and Stanford and IIT and different places all around the world trying to figure out AI. And then there's a guy on Twitter who basically his avatar is an anime character, and he's out training models with hundreds of thousands of, his models are like the best models on the open source leaderboards because they're just trying. Like, you don't, like, it's almost as if you know too much, you get lost in what you know and you don't try things. So there are all these engineers building things. They're building AI that can code, and they're trying to build AI lawyers and AI doctors and AI avatars for video games and AI girlfriends, which is really creepy. And and nobody knows, like there are huge questions like, do you need to have like Zuckerberg just announced he's going to buy $20 billion worth of GPUs. 20 billion. How much? I mean, it's 20 billion, right? That's like a semiconductor fab. And then there are other people like he's going to try to build the biggest AI you can. And then there are people like just trying to, like, how much can we squeeze into a little 1 billion parameter model? How much can we squeeze into a 7 billion parameter model? Can we take a bunch of models that are trained in different ways and merge them? And that's like the new thing. Like this week, the thing was you can merge models. Who would think that would work? But it seems to work. So we just don't know. And I think you just have everyone is trying to do this. And sort of my approach is, I don't have $20 billion to buy compute time. So I just go back to my theoretical physics and try to understand things from that perspective. Other people are just, well, I'm going to go out and get a gaming machine and just train whatever I can train and see what happens.
Right.
It's just, and the challenge is, like, people don't really know why things work. So they'll build something and they test it. I have no idea why this doesn't work. Like, it just fails. We have no idea why it fails. And you're on Discord channels. Like, I'm on the Discord channels where all the gamers are. But this is like the new type of video gaming. Instead of playing a game, you try to train your own AI, and then you try to figure out and people are trying to figure out what works and what doesn't. And there's a lot of folklore. There's a lot of folklore. There's a lot of sort of rules of thumb. And some people think things work and they don't. You don't really know why. It's like a type of chemistry to me.
Right.
It's not like we know what's going on.
Right.
We're just sort of mixing stuff together and hoping it doesn't blow up.
Wow. So at this point in time, what I'm getting from you is AI is still a black box, but still people around the world, the top researchers are going bonkers and trying to build AGI. at this point in time, I mean, you mentioned, there's a team which is building AGI for medicine, so the term itself is kind of like, I mean, it's hazy because, what is actually an AGI? Is it like, what would AGI do? Would it have human level intelligent? Would it go beyond? You mentioned that there's big techs working on it. There's Google, there's Meta, there's OpenAI, there's DeepMind, and there's startups. So what's your intuition like? In this trying to build an AGI, would like a normal small team be able to kind of find the answer, because it's quite hazy? And what do you think is the approach? Could it be just data? Could it be just maybe compute? Would it be like
Well,
a brain inspired approach? What's the intuition in?
It's everything under the sun. But the AI in at least the next year or two will act like an assistant. It won't totally replace the human, but it will make people who are okay much, much better. People who can kind of do basic tasks will get much, much better. Like if you're an okay software engineer and you have a lot of experience in software engineering, you understand you're going to become a really good software engineer. If you're an okay paralegal, you're going to become a really good paralegal because you're going to have this tremendous tool to assist you. Will it eventually replace people? Well, it's going to make people better. Like for example, there's a new study that came out that shows people play AlphaGo. Remember, AlphaGo is this Chinese checkers, right? I guess that's what they call it. I type of Chinese checker. It's what we call it, Go. Well, now the Go players are getting better because they're playing the AI, and because they're playing the AI, they have to beat the AI. They've got to get, so their performance is getting better. So I think when you start getting these intelligent systems and people are interacting with them, we're going to get smarter. It's going to raise the level for everybody. But you've got to be in the game. You got to be using it. I tell my nieces and nephews, you should be using ChatGPT because you got to learn how it works. It's getting better and better. Will it be, I saw a really, is it going to do crazy stuff? I saw a presentation by Palantir where they have the AI in the warfighter. So it looks at the entire warfighting regime and suggests strategies. That's pretty crazy, right? But I mean, that's like what you would do in a large scale video game. So I think these things are coming. The thing is, though, much like, we don't fly the way a bird flies, the AI isn't going to be like us. It's going to be something different. It's going to be much more advanced, and yet at the same time, seemingly not advanced at all. Right. Almost like an autistic child, like who can do all these amazing things, but can't really function. Right. A little bit like Sheldon on Big Bang Theory.
Right.
That's what it's going to be like.
Yeah, so I think amazing things happening because, Charles, I think the tech stack is converging. I've been invested in Metaverse, and we building these virtual worlds, and we have these AI NPCs, conversational AI NPCs, which can actually converse with you, and it's got like a backlog of data, and you can go in through a specific topic, and it gets very, very interesting. Now, you also run a company called Calculation Consulting, and you also have a tool called Weight Watchers. Would you like to talk about Calculation Consulting,
sure.
tool, and also how you help businesses and maybe share some examples on how it's added value?
Sure. So Weight Watcher is a tool which I've invented. It's an implementation of my theory. And what it allows you to do is it allows you to evaluate your LLMs to see if they're being trained properly. So it allows you, and so I'm trying to use it to help people who are fine-tuning models, in particular, like in search relevance, or in other areas where you're trying to fine tune and make custom models. And the idea of the tool is that we can monitor the model to make sure you don't overfit to the data and that the internals of the model work correctly. Because one of the big problems in fine tuning models is nobody knows really what to do. Like, how does it really work? Like we don't really understand how to do it. So people are just kind of guessing, and they're trying lots of different things. And that gets to be very time consuming, very expensive, and very brittle. So the goal of the tool is to provide, some insight into the model so we can train a model. You can take 2 or 3 models, you can compare them and go, I think this model is better than that one. And then you don't have this ambiguity of, well, I need to run this intelligence test. Well, I need to run this evaluation. Well, I need to see if it hallucinates. I mean, that's downstream. My concern is more, can we just get something reasonably effective that's not going to break? And sort of the goal of the tool is to help people when they're training their models. It's just right now a diagnostic tool. I'm building it out as a SaaS product so people would be able to upload models like a monitoring service, like a model alert system. And that's where it is. And I've been mostly helping people who, a lot of it has been strategy consulting, people who want to figure out, what should I do? How does this technology work? What can I build with it? And showing them, what can you really build with prompt tuning? What can you do with fine tuning? I think search relevance is one of the best examples. There are so many companies that they're trying to build search products. They're trying to change the search interface, and they don't really know how to optimize search. I mean, search is really hard. That's why Google's been one of the, Amazon, Google, the top companies in the world, why their search is so good. And so what we're trying to do is figure out how can we design products where you can learn from your user interactions. Because you want to design search products that can learn from the user. So whenever they search for something, they get something better. It's one of these things where people right now are just getting into this fine tuning. They're just starting it. And I think this is the year where it's going to become more prevalent. It's easier to do. A value add would be, for example, I mean, it's very technical stuff. Like, I have to do this search ranking and I have to choose a size for the matrix. And there's one person we were working with, and he had all the, the neural network consists of layers, and one of the layers showed like a warning flag. And so I go, you got to go in and adjust the learning rate on this layer, and the warning flag goes away. And so the goal is to help people build small models that act like the big models. Another value is that we want to make sure you're not you don't want to build models where you want to have just enough data, but not too much. Because if you have to, or you don't want to have models that are so big that you don't have enough data for them, because then you just end up wasting a lot of compute time. I have one customer come to me and said they're thinking about using it as a sort of carbon footprint tool. Like, you can look at your model and ask, what is your carbon footprint of the model, to make sure you're not wasting energy training it. So it's basically, we go and help people build AI solutions, a lot of in search relevance. We've done some work in medical. We build these, we try to fine tune these models. The last big client I worked with was called GLG. They're a consulting firm in New York, and they're an expert system. So when people come in, they have a question. I want to find someone to answer. Are you a doctor who has prescribed this specific drug? I'd like to know how the drug works. Some hedge fund. And then we go through our database, and then the client would try to find doctors. And I was trying to help them build a search system that would match this complex question that a client would have with the consultant. And then, they hire the consultant for like $300, $400, $500 an hour to work with them to answer these questions. So these are big money things. You want to get the match right. And they're very complex questions. So this sort of complex natural language processing and matching.
Lovely. How cool is that, Charles? Because I guess, we're getting into a world where I think data is the new oil, and you have these AI and machine learning tools which can infer a large amount of data and kind of bring you insights, which, it's extremely difficult to get. And through those insights, you can build really good quality products and help businesses, service and solutions. My last question to you, Charles, you've been invested in the space for the longest time. How do you see this pan out? Because you mentioned there's lots of pros and cons. There are the people, researchers at the forefront also talking about, yes, we need to build these tools, which you also through the course of the conversation pointed out that, there's something which is happening, which behind it, which we really, really don't understand. So there are people like Eliza Yudkowsky and many others who are saying that, AI could be an existential threat, and there's others who also are saying this. Even right now, these tools, LLMs, can hallucinate, and and then it creates a generation, the new generation, thinking, oh, these answers are right. So there's a lot of impact that it's creating, positives and negatives. How do you see this panning out? Because there's a huge race, AI arm race. Everybody wants to get it. Everybody wants to build it, without any objective of making sure that this tool needs to be in the hand of the humans, and the right humans rather than the wrong side of the space. How do you see this pan out?
I think it's going to be a lot like, I think there are going to be a lot of big players that try to build models, and they're going to have to deal with this hallucination problem. And I mean, I would always advise clients, if you're doing AI, don't try to build a diagnostic system. Build something that if it makes a mistake, it's not a big deal, right? If you're just ordering things on a search page, it's not going to kill you if the product the user wants is 5 steps down. But if you misdiagnose someone, you could have a big problem. So you want to design systems that I think they're going to appear in environments where they're not man critical, where the chance of failure is not going to cause a huge problem, because the companies that do this and have big failures are going to go out of business. I think that it's soon I think that in the software industry, everyone and their brother is going to want to fine tune their own models. They're going to want to make their own custom models, and they're going to need a lot of help doing it. I think that you're already seeing now huge advances in productivity. Microsoft, co-pilots are going to be the next big thing. And I think that some of the co-pilots are going to require, like any co-pilot, you have to be able to fly the plane even with your co-pilot. You can't just put a co-pilot in the plane without someone who knows what they're doing. They'll crash the plane. And so people are going to have to learn how to interact with these systems and be effective with them. I think it's going to be similar to how Google works, where Google or search engines, when if you search for something on Google and the first result comes up, people just assume that's the most authoritative result. That's not the most authoritative result. That's the most popular result, right? That may not be the best result. And if you just take that as the best result, well, you're going to get, a third-rate answer. And if you know what you're doing, you need to go and try to figure out what the best result is. I am astounded that I mean, I saw this case. You see that Donald Trump's ex-lawyer. What was this guy? They call him the Rat. What was his name? I don't know if you guys follow it over here. Over here is big news. This guy, Michael Cohen, had gone and he'd used ChatGPT to file a legal brief and do the research. He submitted to the judge, these are fake cases. What is this? What is this? This guy's an idiot. But, the problem is it's true. People will use these systems assuming everything is true and real. Those kinds of people are not going to survive very long because they're not going to check their work. And I think that the products that come out will be products that allow you to check your work. One of the things you can do with Weight Watchers, you can actually analyze the base model you're using to tell how likely it is to hallucinate, which is somewhat surprising. But I think people are going to try to solve the hallucination problem in very fixed context. And you're going to have to build systems which check to make sure that you're getting the results you want for what you're doing. And it's going to be a challenge. Now, maybe someone in the next year or so will figure out ways to prevent the things from hallucinating, and they'll be able to make things that are self-consistent and can look up references. When you use ChatGPT now, it will go to Bing and look up the reference for you. But they still do hallucinate. So it's going to be a problem because people have to understand that what you're doing, what you're using, and I think it's going to be, but this is where the world is going. I think the other challenge is a lot of people have raised a lot of money to do AI, and they've got to prove that they can actually generate revenue. And not so easy, right? So I've been in this business a long time. I do freelance work. So, if I give a client a product that doesn't work, they don't pay me. So the academics are going to find out this stuff has to work. So you've got to build things. And the other thing is, I think there will be more humans in the loop than we expect. Like, you might have a product where there are 10 humans in a call center, and you might be able to replace 9 of them. You still need that one human in the loop. That one human in the loop to check things, but the AI can act as an assistant. So it's not fully autonomous. It's just an assistant where there's a human making sure that things are done, more data. And I think that's where it will go.
All right, Charles, really, really appreciate you taking time and being part of the podcast. We're sitting in such a fantastic point of time, because for the first time in human history, we figured out a technology which is somewhat self-learning. And I think you mentioned, the analogy that you gave that, AI is like a steam engine, or the first time when we fly. But I think we're in space which is not linear, it's exponential, from the steam engine, like going towards a rocket. I don't know, would that be possible, not possible? But I think we living in a world where we really don't know. We don't have an answer, because AI itself is a black box. It's got so many problems, but the world is running because we live in a capitalistic world, and we run where the money is, with just blinders on. But I hope that we go towards and create a concerted effort, try to first understand what's happening behind the AI, and build systems which is for the human good, the larger good, rather than possibly, just going behind, these huge dollars you mentioned, or $200 million seed money.
Well,
And how will
I
they generate revenue? Nobody knows, because we're getting into a world which is so competitive. Because unlike 15 or 20 years back, the world has gone so close, and what possibly we're building in India is being sold in America. What's building in China is being sold around the world. Some building in some, like, very, like, maybe like a very unknown place is being sold around the world. So there's more and more competitive world, and in this competitive world, how do you generate revenue with two? And so I don't really know, but I
no,
think exciting
I
world.
from a physics perspective, so much of it is frustrating. Look, I think AI, one of the things that AI can do is it can translate. So in principle, I think if Zoom had an AI system and I could talk to you in a different language, it would translate in real time. We heard the president of Argentina gave a speech at the World Economic Forum. And it was Elon Musk posted this on Twitter, and it was translated in real time in his accent in English for us. It translates in English in his accent. So AI has the potential to connect people together, and I think it has the potential to raise people up. I think that, like with many things, like with nuclear power, we invented nuclear power. I knew Enrico Fermi's family when I was at University of Chicago. Everybody knew him. The family was there. Very famous. He invented a fission reactor. Well, you can build nuclear fission reactors, or you can build bombs. And the technology, if we build more fission reactors, a lot of the climate change problems may go away, or at least we get to mitigate them. If we build bombs, well, that's let's try not so great. If we start using them, that would be a bad thing. I think the same thing with AI is that it has tremendous potential to connect people together, and to lift them up and make everybody better, and to provide all sorts of opportunity. But at the same time, it has to be in the right hands. And if it gets into the wrong hands, it could be very problematic. It could be tremendous cybersecurity issues, tremendous, using it in warfare or terrorism. So tremendous problems, and we have to deal with it. We have to get a handle on how these things work so we can deal with these issues. And I'm hopeful, I'm more of like a Marc Andreessen techno optimist, and I think you are too with the background. That's it, right? Looks like a good place to live. We went from, in 50 years, we went from some bicycle mechanics in Ohio. I'm from Ohio, from flying the Wright brothers in Ohio to landing on the moon. 50 years, right? 50 years we're able to do this. So what's going to happen with ChatGPT, when my nieces and nephews are my age? And your kids are, they're going to be able to do, it's going to just transform things tremendously. But I think we do need to we have to understand what it's doing. And so we have at least some idea of what we're building. And we obviously don't want it to be in just one monopoly's hand. Do we want Microsoft to own everything? Right. That can't be good. Right.
Right.
Or do we want the government to control it? Well, the government has not always been on our side. The government is, we want to have it. That's why the open source community, Weight Watchers open source. I do consulting work, but the tool we provided for people, we try to make an open source community so everyone has access to it and everyone can do things with it and everyone can begin to understand it. I think you need to get involved. I mean, if anything, I think ChatGPT sort of opened up everybody's eyes and said, okay, this is real. Like, this is not like an academic project anymore. This is a big deal. And I think it's a lot like nuclear power, that we have to get behind it and really spend the time to understand it. We invented nuclear power before we had modern theoretical physics. People don't realize it was all based on like the liquid. I mean, there are any physicists in the audience, is the liquid drop model. We didn't have advanced quantum mechanics and quantum field theory and all this stuff. It was all of nuclear physics was based on semi-empirical theories. So we built the bomb understanding almost nothing about nuclear physics. And so hopefully, we will, with AI, we'll get to a point where we can really kind of guide it and understand what we're building and how it functions, and try to avoid the problems that people, inevitably, cause,
Right.
wrong people doing it. We just have to stay ahead of them.
Right.
Just,
Yes. Right. Completely appreciate it. In a profound note to end on, Charles. Really appreciate you taking time and being part of the podcast.
Eddie, I
And-
appreciate it too. I love talking. I mean, I stay up all night talking about this stuff. It's all I think about day and night.
Thank you. We wish you the
All right,
very
thank
best.
you.
I'm going to leave all your connections, your email connects below, so people can reach out to my listeners. If you like what you
Fantastic.
see in here, then please press the subscribe button. Until next time, see you guys. Bye bye.
Hey,
Thank you.
thanks
Appreciate
again.
it.
Have a great day.